Right, personal engagement is a tricky one to try and examine because it has to really genuinely come from you. Now, in the terms of an investigation, the best way to get maximum credit on personal engagement is to choose something that genuinely means something to you. Choose a topic that you find interesting. Choose a question that you're genuinely curious about. This should then shine through in how creative you are and how genuinely interested you are in solving a problem. Initiative in design means you're original. You can't just take an idea from the internet. You can't just start an investigation by trying to look for something that's been done before. You have to genuinely try and be original and implement some ideas of your own. It is tricky, but once you've done this a couple of times, you should get much better at it. Now, the exploration is mainly composed of two different sections. You have the first section, which is your research, and then you have the second section, which is your method. Now, your research has to be complete to the point where it's easy to understand how you got from your topic to your research question. You need to provide enough information about the topics that you can investigate, not the topics, but the variables that you can investigate within your topic and how they lead to your research question. So if you think about something like Murphy's Law, the topic idea would be a little bit just a background into what Murphy's Law actually is, a breakdown of all the variables that you could possibly investigate, and then you choosing a research question, choosing an independent variable and a dependent variable. So that's the first part. Once you have your independent variable and your dependent variable, you need to show that you understand what you think should happen using the theory. So let's say for your Murphy's Law that you've decided to investigate how does the amount of butter or jam, how does that affect the point at which the toast flips? Okay, so your exploration has allowed you to identify these variables, but now your exploration, and this is where you get most of the marks for, your exploration will allow you to predict what actually happens. So you would have to go off and do some research on how does the mass of butter affect the trajectory or the motion of the object as it's falling. Now, you do not have to do that for this experiment, and that's why I've got little lines along here. But for your other investigations, it's important that you do this. Okay, so just to explain that again, okay, your topic is general. You use the general aspects of your topic to narrow down all the possible variables that you can to give you a nice research question. You identify an independent variable and a dependent variable, and then you use theory to explain what your prediction of the effect might be. The second part of the exploration is to do with the method. So that's this bit here, okay? Now, the level of detail that's needed by a method is such that somebody on the other side of the planet could take your report and could simulate your experiment perfectly. As you can see, bullet points come in very useful. So you can present your information with some very simple bullets. Your scientific diagram must be clear, labeled, And if done hand-drawn, which is very, very unlikely, then a pencil and a ruler would be used. If you're not doing it by hand, then you need to use some kind of software which will allow you to draw very neat, clear scientific diagrams. Scientific diagrams are two-dimensional and are always labelled with, very importantly, the variables that you're using. So if there's any way to show those variables on your diagram, that'll be brilliant. Let me give you the example of the acceleration due to gravity experiment. You have a ball dropped, you need a ruler. Okay, now this is obviously not a scientific diagram. Okay, and what we mean by variables is that you would label, for example, the distance that you used. Okay, so this, you would have this labeled as ruler, the ball labeled as the ball, but you would also make sure you showed that this was a marker for measuring the distance. Any safety issues must be highlighted in order to get full credit. And then the next bit is your variables. Your independent variable collection is described fully. Now, in the acceleration due to gravity experiment, your independent variable was the distance. So what do I mean by independent variable collection described fully? You would state how many measurements, in this case at least 5 different heights from the floor to where? Well, I would assume that you marked a point where you were going to drop this from. So it would be the measured distance from the floor up to my starting point. I would measure it with a millimeter ruler, so you would state the precision, and you would also discuss your range. I incremented S up by 10 centimeters each time I did the experiment, and up until a maximum of 2 meters. So it's important to talk about your range, and as I've already mentioned, you would state that you had 5 different readings. Okay, so you have the number of readings, the range, and any precautions that you took in measuring, and of course the instrument and its precision. What does this mean? The dependent variable measurement fully described. Well, in this experiment again, once you dropped your ball, you took a time t. Okay, so you would say what you timed, when you started and when you finished. So I timed how long it took the ball to go from the marker where it was initially placed to reach the floor. I used a stopwatch of a precision of 0.01 seconds. Okay, so you try and be as specific as possible. You would also mention that you took 2 or 3 or 4, how many readings you did, and that you worked out an average. Okay, so that's the level of detail we need for our dependent variable. What you measured, with what instrument, and exactly how. Your control variables need to be listed. What are control variables? All the variables that you must keep constant in order to keep your experiment fair. So you would say how you controlled the variables, and specifically, how did you do this? So if we go back to this experiment here, how did you control the variables? Well, you had to make sure that you always started at the right point, and you avoided parallax errors by making sure that your eye was level. So the control variable was the part of the ball that you measured from. Okay, so you could have started at the top or the center or the bottom, but you ensured that that height was accurately placed by avoiding parallax errors. You could have ensured that the ball was the same shape if it was made out of plasticine. So You could have measured the diameter and then made sure that each time you did the experiment, you kept the diameter constant. And you checked that with a ruler, millimeter ruler, which you always used. Okay, so it's not just about listing the control, it's saying specifically how you controlled it as well.